Okay, continuing on the answers for Module 12, review number 1, number 11, given the recursive rule for an arithmetic sequence, write the explicit rule. So the recursive rule is starting at f of 1 equals 2. So we know that a is equal to 2. And looks like the common difference is 5. So given those two values, we can go ahead and determine the f of n value. Remember, when we start with f of 1, that means we're going to need the formula that says f of n equals a plus d times n minus 1. So a is 2 plus 5 is common difference, and then n minus 1. So you can leave it in this form, or you can simplify it by distributing the 5, and it will give you 5n minus 5. Combining the 2 and negative 5, you have negative 3 plus 5n. And then describing the domain will be n greater than or equal to 1, because we started with 1 as the answer. So that is the formula for number 11. Or like I said, you can leave it in the original form that we have here, whichever you prefer. Number 12, we're starting with f of 0. So once again, we have a is equal to 24. Even though that's f of 0, that's still the initial value. And then it looks like it is minus 4. That is the common difference. So d equals negative 4. And so with the formula, we can go ahead and write f of n. Remember, the f of n formula for n equal to 0 is just a plus common difference times n. So that would be a, which is 24, plus common difference is negative 4. So instead of plus, it'll be a minus 4 times n. And that is my formula. And the domain is for n is greater than or equal to 0. Number 13, given the table for an arithmetic sequence, write the explicit formula, explicit rule. So it's telling you that this is arithmetic, which means we're either going to be adding or subtracting. So let's see what is the value. It looks like we are adding 5 to each one. So that's pretty consistent. So we can conclude that common difference equals 5. And we can also state that the initial value, a equals 4. Again, you are flexible to use either the n equal to 0 or n equal to 1. Either way is fine. You can end up with the same answer or the equivalent formula. So you can go f of n is equal to a. If you want to start with the 0 term, that will be 4 plus common difference is 5n. That will be one form. And then if you want to use the n equal to 1 formula, then you're going to start with 9. So that will be 9 plus 5 times n minus 1. Notice, once again, if I simplify this right here, I'll get 9 plus 5n minus 5, which gives me 4 plus 5n, which is the same exact formula as the one on top. So that is what I mean. Either one of these equations is fine. Let's take a look at number 14. We're given a table. Again, here it looks like you're adding 3. So common difference is 3, and that's pretty consistent. So a is equal to 10 in this case. We have no option to start with 0. It is not given. So we're going to use the n equals 1 formula for sure. And then common difference is equal to 3. So we have the formula f of n equals initial value, which is 10, plus 3, that's the common difference, times n minus 1. You can leave it at this as your answer, or you can simplify it. If you want to simplify it, that will be 3n minus 3, and then you have a 10 in the front. So that'll be 7 plus 3n. So again, either this form or this form is fine. And then if you want to state the domain, that will be n greater than or equal to 1. For the one above, it's n greater than or equal to 0 for the top formula. And then the bottom formula is for n greater than or equal to 1. So whichever one you want to state. Number 15, complete the table of values for the sequence. So we're going to start with the initial value of 16. And it looks like the ratio is 1/4. That means you times multiplying by 1/4. That's going to be like the same thing as dividing by 4. So you get 4. And then after that, you do 1/4 of that. That should give you 1. And then you go 1/4, which gives you 1/4 times 1/4 again should be 1/16. And then number 16 says graph the sequence described by the table. So we're going to use the table. So from 0, we start with 15, which is like right there. And then when n is 1, then it is 7.5. So like somewhere over here. When n is 2, it is actually, it's going by 2, right? So it's 7.5. And then at 2, it's 3.75, which is like right there. At 3 is 1.875, which is like right there. And number 4 is like less than 1. So as you can see, it is going in a curving down motion, which is like called an exponential decay because the numbers are getting less. And that's the end of the problem. Number 17, how many terms are there in the series? So since there's 3 dots in the middle, we don't know how many terms. We don't know what n equals to. So we're really looking for just n in this problem. But we need to revert back to the formula f of n equals, this is a geometric sequence. Looks like it's consistently multiplying by 2. So we know that initial value is a is 3. The ratio is 2. And we don't know n. So we're going to set it up using the f of n formula. So that's a r to the n minus 1. We're going to let 384 equals f of n. Substitute our a, which is 3. The ratio is 2. And then we have n minus 1. First thing we're going to do is divide by 3. So 384 divided by 3, which is 128, is equal to 2 to the n minus 1. So I'm going to rewrite the 128 as a 2 to the something power is equal to 2 to the n minus 1. And you can use a calculator to play around, and you should get 2 to the 7 is equal to 128. So then setting, because the base are equal, the exponent 7 is equal to n minus 1. Adding 1 to both sides should give you n equals 8. So there are 8 terms in this series, and C is the correct answer. Number 18, what is the sum of the series with the first term of 5? Common ratio. So they're giving you the value. So all we need to do is identify what is A, N, R. So A is the initial value. First term is 5. Common ratio is 2, and there are 6 terms. So we're going to use the formula S of n equals a times 1 minus r to the n over 1 minus r, substituting a in, which is 5. That's 1 minus the ratio, it's 2. We have, we're looking for s of 6 because n equals 6 over 1 minus 2. And so doing the math, I'm going to just summarize the top 2 to the 6, make it negative, add 1. So I should have negative 63. And then on the bottom is a negative 1. So divided by negative 1 times that by 5, the answer should be 315, and that is answer choice B. The last question, how many terms are in the series? Again, it's just like the other problem that we did, exactly the same as number 17. So make sure you guys try the problem before you look at the answer, okay? So once again, we know that A is equal to 4, that's the first term. And R looks like it is times 3. So that's 3. And we do not know n. So that's why we're going to solve for it. So we're going to use the formula f of n equals a r to the n minus 1. And we're going to let f of n equals 8748 since we know what that is. Substituting a, which is 4, ratio is 3 to the n minus 1. First thing, we will divide it by 4 to make that problem smaller. And that'll be 2187 equals to 3 to the n minus 1. And I'm going to rewrite it again as base of 3 on the left side. So I'm going to start playing with it, and it should get 3 to the 7 should give me n 2187. And base are equal, so exponents are equal. 7 equals n minus 1. Adding 1 to both sides, so I have n equals 8. And therefore, the answer choice is A. And that is the end of this review. So hopefully that helps you to study for tomorrow's test. Please watch the videos as many times as you want. Good luck with you. Please study and be prepared for the test. See you guys later.